Firstly, welcome everyone to this seminar series of CU Ethics and Mathematics Society. Who hasn't been to Cooling's events before? Hands up. It's a lot. Okay, good. New fresh faces. Excellent. It'll be fun. Right, so the society was formed in 2015, which for most of you means forever, because it was before you came here. And the aim is to start a discussion about mathematics and its impact in the world. This room and what's happening today is unique because there is no other room in the world in the math faculty where this is happening. We are the only ones currently speaking about this in any sort of organized, proactive way. Maybe some odd thing happening here and there, but in terms of an organized series, organized in society, we are the only ones, and we're the first. Which is not what we want. We want to be in a large company of people. But we're working on that. So, my name is Maurice Chiodo. I'm a postdoctoral researcher in DIPMS. I work on algebra and logic. And in my spare time, I tell mathematicians how to behave. Because no one else ever does. We teach you mathematics, teach you how to solve equations and take derivatives and things like this, but we don't teach you when you should be solving equations or whether you should be taking derivatives. We just say, here's how to do it, good luck. And hope to God that you don't mess anything up. And sometimes you do. Sometimes we do. So these are going to be fairly interactive lectures. They'll be very different to what you're currently used to. So it's not just going to be me talking for 1 hour. I might talk for 30, 35 minutes, and then really try and get everyone engaged in a discussion. Because ethics is not axiomatized. I can't just write down a nice algorithm or set of rules for you, like I would define a vector space. Ethics is a bit more complicated. And you have to actually sort of think about it and get your hands dirty in the process of pondering what the issues are. So once I finish giving a bit of a longer spiel, we'll go into discussion, which is important. So what might I want to start with? Let's think about what happens when we do mathematics. So what might a mathematical problem be? Well, let's try one, shall we? So I have a shore, and I have here lovely waves. This is the ocean. And in the ocean I have an oil rig. We drill for oil. And over here on the shore I have a refinery. You turn the oil into petrol for your cars. So I want to build a pipe from the oil rig to the refinery. How might I do this? Well, I don't just want to build any old pipe, with some crazy path. I want to build the optimal pipe from the rig to the refinery. So maybe I know that, the cost under water of the pipe is, say, alpha dollars a kilometre in the UK, so we use pounds, and cost on land is beta pounds per kilometre. And I know that from the perpendicular, this is d kilometres. Where the oil rig would sit on the perpendicular. So a nice straight shoreline here. So how might I compute the optimal path from the oil rig to the refinery? Well, I might ask myself, well, do I have enough information here? I've got the cost of the pipe over here, I've got the cost of the pipe over here. Now, I've run this several times with students where I bring students up to the front. Today I'm not going to do that, I'm going to work things a bit faster. So I bring students up to the front and everyone says, well, we can't solve that yet. Why can't we solve that yet? Here it is. That's correct. I don't have the distance here. And often what I do is I deliberately leave that off, and then students come up and say, well, this is, we can't solve this, we don't have that distance. And everyone asks that question, what's the distance? And I tell them, and I say, okay. And then everyone's happy. And then people start doing things like this, and trigonometry, and then there's the here. And eventually you get, well, many students get some sort of pipe that looks like this. Remember the question I asked was the optimal path for the pipe. Now, subject to me doing the trigonometry or the calculus correctly, who thinks that this is roughly what the optimal path for the pipe should look like? Give or take. Relatively happy. I think this is maybe comes up even on a late high school challenging exam question, something like this. Okay. But have we really answered the question?
No. Yeah.
Congratulations. It usually takes people a lot longer to get to that point. I never said what I was optimizing over. Maybe I'm the pipe seller. And I want to sell as much pipe as possible. I'm the pipe installer. I just had my house renovated. Trust me, these guys will sell you gold-plated pipes if they could. Right? 600-mile pipe to go 1.5 miles. Right? This thing goes via Amsterdam and back. Maybe I'm the pipe seller, in which case I want to maximize the amount of pipe that's going on. What else could I be that might impact how I'm doing this optimization? The pipe seller wants to sell more pipe. Or a company, what do they want to do? They don't want to spend much money. They've got shareholders and they've got lavish parties to have on the 700-story buildings or whatever. So they don't want to waste money building pipes. Anyone else I'm going to think about? There could be some stuff here. What sort of stuff might I run into in the middle of the ocean? Kind of not too far from the shore. I'm from Australia, we have a big one of these. Barrier reefs. Maybe a reef. Or an island with some little sort of protected bird, of which there are only 3. Right, you want to build a pipe right down the middle of that, you're going to cause problems. What other stuff might there be? Maybe there's no environmental cost whatsoever. This is just crappy ocean. Yeah. Maybe some poor schmuck lives here. Or maybe there's an orphanage here. Everyone always laughs when I write orphanage.
Home for retired mathematicians.
We don't get to live that long to get to retirement. Maybe Euler's grave is here or something, I don't know. I mean, you're going to bulldoze straight through Euler's grave to build your pipe. Okay, so we've got environmental cost, we've got financial cost, we've got Mr. Pipe Man who wants to sell as much pipe as possible. We've got the poor orphans sitting here who just have their orphanage bulldozed. The list is endless. The reason I raise this is for 2 things. One, whenever I open my mouth to mathematicians and say optimal, the way you pass that is, optimal is equal to either time or money. Sorry, we're in the UK. we optimize. Give me the cheapest one and give it to me fastest. Is that how you go and order your dinner when you go to a restaurant? What's the optimal meal I should have? Well, give me the cheapest bowl of calories as quickly as you can. And someone brings you a stick of butter. Yeah, an awesome meal. I optimized. No, of course not. There are other things to consider. The second thing is, I gave you some information. Now, is this a mathematical problem? If not, then what is it? If so, explain. What was the problem I put on the board? It's always good. There's a grain of sand here I never told you about. Woo. There is a rig. There is a refinery. Build a pipe. Newton wasn't thinking that when he was under the apple tree. This is a real problem that someone's going to want to solve. We come along and say, okay, we can use some math on this. We convert this mess into this stuff. Some calculus, some trigonometry. And we think about it, and provided we don't screw it up completely, we give back some sort of semi-sensible answer. And that answer then goes back into a real-world scenario. My answer is going to solve a real-world problem, a physical problem. Mathematics is not a physical thing. I can't pick up mathematics and give it to you. I can give you a book with human words in it, but I can't give you mathematics. So the key here is asking questions. We're extraordinarily good at solving other people's problems, answering questions. When do we ask questions? Who here has ever been given a mathematical problem and before doing anything has asked further questions about the problem? 1, 2, getting on half-ish, if that. But there are lots of questions to ask about this. Lots and lots of questions. We don't tend to do that. We're not encouraged or trained to do that. We're encouraged to take what we're given and play with it. Here are your parameters, here's what you can build between, this is the cost, give me the optimal. What's optimal? What else is there? What stuff is around? Maybe your own house is there. You never asked where this was. So you designed this pipe, well, that was great, I just got paid, go to my beach house, I've got no beach house, I've got a pipe house. You can also, sink your own boat in doing this. Why do I say that we should ask questions? Maybe you think, you know what, I'm a mathematician. It's reef, orphanage, it's not my problem. I do the math. I can do calculus, I can do trigonometry. Someone else will give me the problem. Okay? Who's that someone else? That someone else is usually some sort of management. What's management optimizing over? Do they care about the environment? Do they care about you and your house? Do they care about orphans? Or do they care about appeasing the shareholders and appeasing the success of that, and promoting the success of the company? If someone's risen to a level of high management, then they're not answering to the world or to you, they're answering to shareholders. They're answering to the success of the company. So they will optimize over that. And they will then structure a question for you based on that. But maybe there's rules and regulations that can come in and kick in here. So even if management is trying to push you to do something in their interests, maybe the law will help you. Law. We do mathematical problems. Who writes the law? You know any mathematicians who write the law? No any mathematicians in Parliament? No any mathematicians who sit on the US Supreme Court? I hear there was a vacancy recently. I didn't see any Fields medalists lining up for the job. No, the law is written by lawyers. Lawyers understand societal concepts. Lawyers understand, what the general person accepts and can agree with. What lawyers generally can't do, apart from being decent human beings, is calculus and trigonometry. This is not their area of expertise. So they write laws with certain things in mind, certain ideas, certain spirits, the spirit of the law. The problem is, we're mathematicians. We can be clever. So the lawyers give us, the lawmakers give us, in a sense, a set of axioms. What are we trained to do almost from birth as mathematicians? Step 1, take the axioms. Step 2, squeeze. We squeeze everything we can out of a set of axioms. And I know a case of an undergraduate student from Rutgers who had a summer project a couple of years ago. And the project was titled as follows: How to extract data using mathematics from data sets where the data you're trying to extract is prohibited by law. Because hey, we're mathematicians, we can do it. Here's your axioms, here's your boundary conditions, whatever you want to call them. Okay, I've got boundary conditions, I've got my axioms. What can I derive? Twofold problem. Firstly, the student thought, yeah, this is a great thing to do. Secondly, some supervisor had to assign that project to a student, had to advertise that project to students. People had to come and put their hand up and apply for that. We openly, knowingly can get around the law by our technical knowledge and understanding. So, if management is unable or unwilling to guide us in a way that moves away from the vested interest of management and the corporation, organisation, whatever it is. If lawmakers and regulators lack the technical understanding to guide us in what to do, and even if they could fully, even if they didn't understand what we're doing, should we expect them to give us a full set of axioms? Now, Gödel comes into play here. I make an axiomatized system. If it's not good enough, it's incomplete. If it's too good, it's inconsistent. You can try and make all the rules you like. You'll either leave gaps, or you'll over-specify the system. And then you get things like 2 = 1 inside your system. So if management can't be trusted to tell us what to do and give us sensible guidance, if regulators and lawmakers can't be trusted to act in full awareness and understanding of what we're doing, who's left? It's a serious question. Who is left on the stack to give us any sort of guidance, any sort of understanding of how to behave when doing mathematics? There's only one person left. You are the only ones that can self-guide, self-govern, self-regulate this. No one else has the right understanding and motivation to do that. That's the key combination there. The manager might understand what's going on, but they're in it for their next bonus and their next promotion. Lawmakers might, regulators might have the right motivation to give you guidance, but they can't do the math. So the words that come out of their mouth, we can literally write summer student projects to circumvent them. And we have done so. So the responsibility lies on us.